This is 1602 liquid crystal display module, in short LCD 1602. After watching this video, you will know some detail about this LCD and will be able to use this to your DIY project. This LCD 1602 display module is very popular and can be easily connected to an Arduino or Raspberry Pi. The display consists of two rows of 16 characters each. The LCD 1602 display has 16 solder pads that we can use in number of ways. We can solder a 16-pin male headers, or we can attach an I2C adapter directly to it. Let's see the pin function of each pin. The first pin is ground pin. On some modules, it is labeled VSS. The second pin, VDD. This is the 5-volt power connection. The third pin is brightness. This is the input for the brightness control voltage, which varies between 0 and 5 volt to control the display brightness. On some module, this pin is labeled as V0. The fourth pin, RS. This is the register select pin. It controls whether the input data is meant to be displayed on the LCD or used as control character. The fifth pin, RW. This pin puts the LCD in either read or write mode. In most cases, we will be using read mode, so this pin can be tied permanently to ground. The sixth pin, EN. This is the enable pin. When high is read, the data applied to the data pins. When low, it executes the commands or displays the data. From pin 7 to 14 are data input pins. These all pins are denoted from D0 to D7. The 15th pin, BLA, is the anode connection to the backlight LED. And the last pin, BLK, which is the pin 16, is the cathode connection to the backlight LED. Let's see the components we need for hooking up the LCD 1602 to an Arduino Uno. We need Arduino Uno and LCD 1602. Then we need a breadboard, one 10 kilo potentiometer to control brightness of the display, one 220 ohm resistor to drop the voltage for the display LCD backlight, and lastly we need some jumper wires for connecting. Now let's see the hardware connection. Take 5 volt and ground from Arduino and put it into the power rail of the breadboard. Place the LCD on the breadboard like this. Connect LCD RS pin to the Arduino digital pin 12. Then LCD enable pin to Arduino digital pin 11. Then LCD data pin 4, D4 to Arduino digital pin 5. LCD D5 pin to Arduino digital pin 4. LCD D6 pin to Arduino digital pin 3. LCD D4 pin to Arduino digital pin 2. Then LCD anode pin to 5 volt by a 220 ohm resistor. LCD cathode pin to ground. LCD read-write pin to ground. LCD VSS pin to ground. LCD VDD pin to 5 volt. Place a 10K potentiometer on the breadboard and connect the ground pin with the ground and VCC pin with 5 volt. After that, take the output and connect it to the LCD brightness pin. After completing the connection, connect the Arduino with computer and open Arduino IDE. Click on the File menu at the top of the IDE. Click on Example. A submenu will open. Scroll down the submenu to the Example from Custom Library section. Select Liquid Crystal. We'll see a section of example sketches. Let's begin with classical example, Hello World. After selecting Hello World, the sketch starts with a number of credit and description of the required hardware hookup. You will note that this is the same hookup we just performed on our Arduino and LCD module. In the beginning of the actual code, we load the liquid crystal library. We then initialize an object that we call LCD using the pin out of the LCD display. If we decide to hook up our display to the different pins, then we need to modify this section. In the setup routine, we initialize the LCD for 1602. If we are using different LCD module, we would change this accordingly. We also write Hello World to our LCD in the setup. We do not specify the cursor location. These will print at the beginning of the first row. Now on to the loop. In the beginning of loop, we sent our cursor to the first position in the second row. Note that the raw numbers start from 0. We then use the millis function to print out every second on the display. That's end the loop. So you start back at the top of the loop and repeat. The result will be a counter on the second line that counts seconds from the time the Arduino was last reset. Upload the sketch to your Arduino and observe the display. If you don't see anything, try adjusting the brightness control that we wired to display. If we connect LCD like this way, we would need some other components such as breadboard, potentiometer and resistor. Also on an Arduino Uno, half of its I/O pins would be taken up by the display, which can be problematic if we want to use the I/O pins for other input or output devices. One way to make the connection easier and reducing the number of connections to the display is to use the I2C adapter. If we use these I2C adapter, then we need just 4 connections and it will take only 2 I/O pins from Arduino. Here I have soldered these I2C adapter with the LCD. In I2C adapter there are 4 pins. The first pin is ground. The second pin is power. It will be connected with 5 volt. The third pin is SDA. This is serial data. This line is used for both transmit and receive. The fourth pin is SCL. This is serial clock. This is a timing signal supplied by the bus master device. Now let's see the connection of this LCD with an Arduino. Arduino ground will be connected to LCD ground pin. Arduino 5V will be connected to LCD VCC pin. Arduino analog pin A4 will be connected to LCD SDA pin. Arduino analog pin A5 will be connected with LCD SCL pin. After finishing hardware hookup, connect the Arduino with computer. Open the Arduino IDE. We have to include a library for the I2C. Click on the Sketch menu at the top of the IDE. Click on Include Library. A sub-menu will open. Click Manage Library. Library Manager will appear. In the search box, type liquid crystal _ I2C. Many libraries will appear. Find the library created by Marco Swatch and then install it. After done installing the library, we could see it's written installed beside the library. Now click on the File menu. Click on Example. A submenu will open. Scroll down the submenu to the Example from Custom Libraries section. Select Liquid Crystal I2C. You will see a section of example sketches. Let's begin with the classical beginning Hello World. In the code, first few lines are comments. Those are not a part of a main code. In Arduino, much like other leading programming platforms, there are built-in libraries that provide basic functionality. Here includes OIL library, then includes Liquid Crystal I2C library, and then set the LCD address. After that, let's come to the setup. Every Arduino sketch must have a setup function. In the setup, we initialize the LCD, and to print a message to LCD, we turn on backlight. In the beginning of the print, we set our cursor to the 4th position in the first row. Note that the column and row numbers start from 0, so the 4th column is 3 and first row is 0. We are printing Hello World. By the same way, we will print other lines. At the end of the code, we left void loop empty. Now let's upload the code. Select board and port before uploading the code. After done uploading, we could see the printing on the display. We can adjust the brightness from the potentiometer of the I2C adapter if we need. Now let's see some changes in cursor position to better understand. Here I'm changing the cursor position to column 0, row 0, so that prints start from the beginning position of the screen. Also, I'm writing good morning instead of hello world. Let's re-upload the code and see. Now let's print my channel name in the second line from the start position. That's interesting, isn't it? In this code, something written for 3rd and 4th line. So if we need more than 2 rows, we could use 1604 LCD. Here I am replacing 1602 with 1604 LCD. Let's write welcome to my channel in the third and fourth line. For third and fourth rows, if we set the column position -4, print will begin from the starting of the rows. I will use this ultrasonic sensor to measure the object distance and will print the distance on the LCD. Let's see the working principle of ultrasonic sensor first. Ultrasonic sensor work by sending out a sound wave at 40 Hz frequency, which is above the range of human hearing. The sound wave travels through the air until it strikes an object. When the sound wave hits an object, it is reflected back to the ultrasonic sensor. The sensor then calculates the time it took for the sound wave to travel to the object and back, and uses this to determine the distance of the object. This is the most popular sensor for measuring distance and making obstacle-avoiding robots with Arduino. This sensor has 4 pins: VCC, ground, trigger, and echo. At first, place the ultrasonic sensor on the breadboard like this. Then we'll hook up the sensor with Arduino. Connect VCC of the ultrasonic sensor to 5V of Arduino. Connect trigger pin of ultrasonic sensor to Arduino digital pin 11. Connect echo pin of ultrasonic sensor to Arduino digital pin 12. And the last pin of ultrasonic sensor, which is ground, will be connected to ground of Arduino. Now we will connect the LCD display. This is LCD display with I2C. It has only 4 pins: ground, VCC, serial data, and serial clock. The ground pin will be connected to ground. Here we can use the same ground pin which we used for ultrasonic sensor. The VCC pin will be connected to 5V. Like the ground pin, here we can use the same 5V pin which we use for ultrasonic sensor. Connect SDA of LCD display to analog pin A4 of Arduino. And lastly, SCL of LCD display to analog pin A5 of Arduino. Let's write the code. In Arduino, like other leading programming platforms, there are built-in libraries that provide basic functionality. We have to include oil library and liquid crystal library. Then we are setting the LCD address. To use the Arduino pins, we need to define which pin is being used and its function. Here we are defining ultrasonic sensor trigger pin 11 and echo pin 12. We need to declare global variables and instance to be used later on. A variable allows us to name and store a value to use in future. Here adding data type long and name 2 variables, duration and dist. Now come to the void setup section. We are adding LCD backlight function to turn on LCD backlight. Then by pin mode function, we are defining the trigger pin will function as output and echo pin will function as input. After end of void setup, let's start the loop. It is the main function and it's run in a loop over and over again. At the beginning of the loop, we are making trigger pin state 0 by digital write function and then making 5 microsecond delay. Now we'll make the trigger pin high to create sound wave. We'll keep the sound wave for 10 microseconds. Then we'll turn off the sound by making trigger pin low. The sensor then calculates the time it took for the sound wave to travel to the object and back. Here in the code, we are getting this duration by pulse in function. To get the distance, we'll divide the duration by 2 as the sound wave traveled 2 times of the object distance. Then we'll further divide it by 29.1. Sound travel 1 centimeter in 29.1 microsecond. That's why we'll divide by 29.1 to get the result in centimeter unit. In the beginning of the print, we are setting our cursor at the first position of the first row. The double quote symbol is used to delineate a string of text. We are printing the word distance in the first position. So whatever you want to print on LCD as a text, it will be inside the double quotes. After that, we are setting our cursor to the first position of the second row. We'll print dist variable value, which is the distance. At the end, we will print our measuring unit of distance and we'll make 1000 microsecond delay and clear the LCD. Here end of loop, and this loop will continue. Now we will upload the code to Arduino. Select the board and port correctly from the tool option and then upload the code. After done uploading, let's test. Thanks for watching. You are welcome to see some other dive videos from my channel.